using open circuit method. Now what is this open circuit method is? So see that where the diode is connected. Now so this symbol is indicating anode and this line is indicating cathode. So represent these levels, voltage levels. Now what is the assumption is simply open the diode. So open means this is R or 1 kilo ohm. So this is VA and this is 5 volts. This is 1 kilo ohm. 1 kilo ohm. Now this is VK. Now if you observe, so open circuit means there is no current. So drop across this resistor will be 0 volts. So VA is directly connected to 5 volt and VK is simply connected to ground. So VK is 0. Now by our assumption, if it is ideal, VA should be greater than VK. If it is a practical, VA minus VK should be greater than 0.7. If these two conditions are satisfied, the diode is in forward bias. Otherwise, diode is in reverse bias. Right? So, if it is ideal, diode is in forward bias means simply short circuit, or if it is a reverse bias, simply open circuit. Now in the practical case, when VA minus VK is greater than 0.7, diode is in forward bias and equivalent model is the voltage drop 0.7 volt. Otherwise, diode is in reverse bias, so simply open circuit. So these two conditions we need to verify. So open the diode, find VA and VK and go with these assumptions. Whenever VA is greater than VK for ideal, you will get forward bias, short circuit. Practical, VA minus VK should be greater than 0.7, diode is forward bias, simply the replace with the 0.7 volt. If it is a reverse bias, for the both conditions it will be open circuit only. Now the gate problem, the previous one what we solved, now we will solve with the open circuit method. Then you will see, we will find the same voltage levels or current values. Now if you take this same circuit again, now what we need to do, replace with open circuit and find VA and VK. Now that is very simple. So that equivalent model will be like this. This is 2 kilo ohm plus minus 2 volt. This is grounded 6 kilo ohm. So I need to open this diode and replace with VA and VK. Now I need a voltage here and I need a voltage here, right? So I can easily find VA. VA is connected to this 2 volt to the ground, so I can directly say VA is equal to 2 volts. Now I need to find VK, right? So I can find VK by applying a KVL, or if I find current here, then I can find easily what is this voltage. So if I say I is flowing, so if you apply KVL, it is minus 2 plus I into 2 plus 6 kilo ohm, so equal to 0. What is I? 2 by 8 kilo ohm, so it is 1 by 4 milliampere or 0.25 milliampere. Now I know I. So what is this voltage I can find? V is equal to 6 kilo ohm into 0.25 milliampere. So kilo will be get cancelled. 6 into 0.25, so 6 by 4, right? 6 by 4 I can get is 1.33, I think 1.33. So 6 divided by 4 is, no, not 1.3, it is 1.5 volts, right? So this voltage is 1.5 volts, right? Now so he said V on should be 0.7. So in this here given V on is 0.7. That means this is a practical diode. So VA is 2 volts, but VK is 1.5 volts. Now what is the difference? VA minus VK, it is only 0.5 volts. But for a practical diode, he mentioned it should be 0.7 volt. So what is this VA minus VK? It is less than 0.7 volt. So simply diode is in reverse bias mode, or it is open circuit. Now if you go again, anyway it is open circuit, so I can find easily I is what? 0.25 milliampere. So this was what we found as in the previous this short circuit method. Using short circuit method also we got same results. So this is 0.25 milliampere. So but by open circuit method this is very easy, right? So in the previous case we have found so many currents, but in this case simply open, find VA and VK. If VA is greater than VK, for ideal case it is forward bias. Whenever it is practical, it should be 0.7. If in the question he mentioned, suppose it is ideal for both on and off, so 2 is a VA, VK is 1.5, so 2 is greater than 1.5, so it will be short circuit if it is ideal.